So this problem is another type of limiting reactant problem, but it gives us a little bit of different conditions. So the example is the following reaction goes to completion in a 6.3 liter vessel at 78 degrees Celsius. And then it gives us a balanced chemical reaction and an initial amount of moles. The vessel contains 2.5 mole of H2 and 1 mole of Cl2 before the reaction took place. So the first question asks to find the mole fraction of the gases present after the reaction is complete. And we're actually, one way to set this up is to set up a chart that'll help us calculate which reactant is the limiting reactant. So when we set up the chart, we're going to have H2 plus Cl2 is going to give us 2 HCl. This is our balanced chemical reaction. We can set up the chart from here, and in our first column, we're going to have our initial values. In our second row, we're going to have the change. And then our third row is going to be our end result. So initially, how many moles of each substance do we have? Well, in the question, it says we have 2.5 mole of H2 and 1 mole of Cl2. So that's what we're going to put in our chart. And we have no initial moles of HCl. In our second row, we're going to use the coefficients in front of the compounds in the balanced chemical reaction. So our change for our reactants, we're going to subtract 1 mole for H2, 1 mole for Cl2, and then for our reactants, we actually add. And we're going to get 2 mole right there. And again, we get these numbers from the balanced chemical equation. So H2 doesn't have a coefficient in front, which is why we used 1. Cl2 doesn't have a coefficient in front, which is why we used 1. And HCl has a coefficient of 2 in front. Get rid of this so as to not confuse you. Now, to get our final amounts, we go through with our calculation. So for H2, we're going to do 2.5 minus 1 and get 1.5. For Cl, we have 1 minus 1, which is 0. And for HCl, we have 0 plus 2, which is 2. Now, what information does this give us? This tells us that the system is going to run out of Cl2 first, because that's our smallest amount of moles. That's going to be our limiting reactant. So when we find the mole fraction, we're not going to include Cl2. So to find the mole fraction for hydrogen, we set up our problem 1.50, sorry, that's a decimal, mole of H2 over 1.5 mole, which is, remember, we're calculating the total in the denominator, plus 2 mole of HCl. Our answer is 0.429. And to calculate the mole fraction of HCl, we're going to put 2 mole of HCl on top of the total mole, which again would be 1.50 plus 2 mole. And that's going to give us 0.3 571. Those are, to answer to answer letter A, find the mole fraction of the gases present. So we have the mole fraction of hydrogen and the mole fraction of HCl. And to check ourselves, when we add up those two numbers, they're going to equal 1. Now, I'm going to erase what I have, and in the next video, I'm going to try to get B and C in together.